Yep. This is looking from the top. You're going to build 3 identical, those don't look identical, but 3 identical enclosures for, let's say, some chickens, and then maybe some, I don't know, pigs, and then goats, and unicorns, whatever it is that you have. And I didn't do a problem like this, right? I didn't do anything like this. Let's say that here's the deal. You have the need to make each pen have an area of, let's say, 30 square feet. What do you think the question is? I was going to start talking like a farmer and start talking about, this, but I don't want to stereotype any farmers. So I'm sitting out there, I'm looking out there going, I want each pen to have 30 square feet so my chickens and pigs and goats are happy. Okay? So what do you think? I mean, probably, I don't know if farmers really think like this. I would hope they do, but how do you, well, who can tell me what the question someone should ask themselves here would be? How much fence do I need, yes, to do this? But a better question would be the least amount of fence I need, right? If I'm paying, fence isn't cheap, right? Especially if I'm going to be putting in like a bunch of barbed wire fence for these chickens and pigs and goats, right? Or whatever it is. It's going to be made out of like platinum or, platinum chain link platinum fence. $300,000 a square foot or something. No. You know what I'm saying? It matters if I can minimize the cost, right? Yes.
It's just random, but like in the area versus siding, the square has the most area for each side. Is the square better than a circle? Just like this, or the circle being the best area for the side?
Okay, so you're saying for a fixed perimeter, what gives you more area, a circle or a square?
Yeah.
Is that what you're asking? Or are you saying?
Well, like the amount of area you get per how much fits you have. Set like what shape is the most area? Yeah.
Okay.
The circle is the
Great question. You can answer that question. Not right now. I mean, you can't maybe think of it, but you can answer that question. How would you answer that question? I'll give you a minute to think about it. I don't want to put you on the spot, but think about it. You're asking a perfect question. If you have some geometric shape that has a fixed perimeter, let's say, what's the optimum shape to get the most area? Is that what you want? Yeah. If you want to compare a square and a circle, you could do that. Yeah. Well, it may not even be that difficult. Yeah, I mean, just pick a number. Yeah, it'll be a circle. Yeah. I mean, have a generic perimeter of 1. Have a generic perimeter of 1, and then figure out from that what the areas of each one would be. Make a square with perimeter of 1 and a circle perimeter of 1. Compute the areas of each one and compare them. So, okay. That reminds me, why are manhole covers circles? Y'all ever heard that one? You've heard that? Manhole covers are round because a circle won't fall into the hole. If you had a square manhole cover, if you turned it on its diagonal, it could fall down into the hole, but circles can't fall into holes. Just kind of random, useless information. Let's get back to the pigs and the goats. It is. And most of the pipes are round too, so it makes sense, you know, but that's not usually it. Yeah. Mm-hmm. All right, okay, so the answer, the question that the farmer should be asking is, how can I make this happen and spend the least amount of money? So I need to buy the least amount of fence, right? Now, let's discuss some things here. Where does the farmer actually need fence? Right here, right here, right here, and right here. Technically, he won't need it along the river if we assume the chickens can't swim. I don't know if chickens can swim. That's true. Okay, well let's make these no, because there's still alligators in there. Why don't we just make this like a tiger so the alligators won't mess with them or something? The idea is just that we don't need fence along there, okay? Or if you don't want to make this too freaking confusing, let's just make this the other part of the barn. The barn makes like an L shape or something. Okay, so we don't need fence up against there. Okay? So what is it that we're trying to optimize? Okay, total length of fence, right? We want to optimize the length of fence. What is the length of the fence? And let's just call it L. How about that for length? What is the length of the fence? Oh yeah, optimize. What do we want? The most or the least? So we want actually to minimize this. So what is the length of that, total length of the fence? I don't know, but I need to start assigning some variables, right? So farmer comes out here and says, okay, I can say that this distance from here to here, I could call that X, right? And I could take distance from here to here and I could call that Y. So what's the total length of fence used then? 3Y plus X. That's my objective equation, isn't it? But I need that in terms of one variable, not two. So there's some other constraint I need to put in place here. What's my constraint? Constraint. What's my constraint? The area must be 30, right? What is the area? I'm not sure. What did I say? Each pen has to have it. Thank you. Each pen has to have an area of 30. Thank you. 90, yes. Yeah, each pen has to have 30, so 30, 30, 30, 90. Okay. So that means the x times the y has to be equal to 90. Do you all agree with that? Because of the way I drew it, x is the entire side, y is the length. So can't I solve that for either x or y? Yes? What do you want? I don't care. X or y? X? Okay. X is equal to 90 over y. So now we come back into our length equation. 3y plus x, but x is 90 over y. Now we're going to run into some issues. Do we have a restriction on y? What's the smallest y could be? 0? Could y be 0? Look at your length equation. Look at your length function. Can y be 0 in here? You divide by 0, right? So I know that y must be bigger than 0, can't be equal. Is there a maximum that y could be? Is there a maximum that it could be? I can make those pins as long as I want, right? The longer they get, the more narrow they get, right? But eventually, I'll reach some restriction. I'll either run out of the barn, right? The barn will get, I'll come off the edge of the barn, in which case all the geometry changes. Or the goats and the pigs, you know, like I can't put them in a 3-inch narrow pen, right? And have it be like 50 feet long. You know what I'm saying? Can't have that happen. So I don't really know what the restriction is on y. I'm going to concede that, which means I'm going to treat it like an open interval problem. Okay? And let's just find a derivative and see where it takes us. So what is the derivative? What is L prime? What's the derivative of 3y? 3. What's the derivative of 90 over y? Negative 90 over y squared. That's just by treating 90 over y as the same as 90y to the negative 1, then taking the derivative. Set that equal to 0. I'm going to move my 90 over y squared to the other side. I'm going to multiply both sides by y squared, divide by 3. Square root of 30. Okay. And I don't have to consider the negative one here, right? I'm going to do open interval method, so I'm going to just look at root 30, pick something to the left and to the right of it, and plug them into the derivative. I'm not going to actually do it, but it's going to go up then down. Oh no, other way. It's going to go down then up. Yep, 5 and 6 would work. And where are you plugging those into? Derivative. So that tells you have a local minimum at y equals the square root of 30, which means that's where you're going to have the least amount of fence. That's what you want. So what's x? 90 over y, right? 90 over root 30. So that's it. I wanted the dimensions or something, or I don't even know what it said. How do you build it, right? That's how you build it. You let your x be 90 over square root of 30, and the other side square root of 30. I'm looking at the time. It's 4:15. I'm just wondering what we might, if we even have time for anything else worthy of doing. Is there anything you want me to talk about or do? We're good? What I'll do is I'll hang out for the next 10, 15 minutes, and I'm going to put in all the quiz grades, drop the lowest, and if you want to hang out, you can. Okay? Just to figure out where you are. Here's the thing, though. It's going to be hard for me to tell you, oh, if I do version 2, then what? I mean, that's going to be a little tough. I might be able to do it quickly, but we'll just see.